are Alejandro, Marco, Juan Camilo, Manuela, Alejandro, students of the Universidad de los Andes, and this is Robocol.
Robocol is a multidisciplinary team created in the year 2011 as a student-driven initiative, with a great total of 25 active members consisting of mechanical and electronical engineering, as well as a team of biologists and geoscientists.
Based on the tests and research carried out by previous and active members throughout the year, the Ucumari Mars rover relies on a rocker bogie traction system.
With this smaller chassis, the operational systems and control devices can be evenly distributed as to maintain the rover's overall center of gravity as close to its midpoint as possible. Keeping this in mind, the complete frame, non-linkage components, and non-specific operational systems have all been designed in aluminum. Due to its light weight, cheap costs, market availability, reduced oxidation, physical properties, and malleability, aluminum is the best option for a project of this scale. Also, the previous bar differential system has been replaced with a new spring-held contraption that allows liberty in rover movement and stress relief when subjected to minor bumps or falls.
Ucumari interacts with the world using a serial manipulator with 6 degrees of freedom. It is actuated by 5 stepper motors and 1 DC linear actuator. The stepper motors have single or dual stage velocity reduction depending on the necessary torque of the joint. The wrist has decoupled kinematics for position and rotation and interchangeable end effectors for the different tasks. Save for the rotatory base, the arm is detachable, lowering the center of gravity of the rover during the autonomous traversal tasks where stability is paramount.
URC 2018, the electronic team decided to back up the different systems in order to carry through the problems that may appear at the competition.
As a central command in the rover, a Raspberry Pi 3 was selected to act as a command coordinator. The Raspberry receives information from the base station, deciding and carrying out instructions to the rest of the rover. It also gives us the possibility to process images in the rover rather than in the base station, allowing us to send less information to the base. On the other hand, we are using OpenMB Cam M7. This camera has a microcontroller on board which runs on Python language, being capable of processing images directly on it. The Raspberry Pi is also in charge of acquiring the GPS data, sending it to the base station via Wi-Fi and using this data from the autonomy test in order to reach the specific target.
Traction, we knew that it was essential to design a possible scenario for the specific terrain we will work in it. The difficulties that Ucumari will face in each of the tasks, in particular the autonomous navigation, it was decided to keep each individual motor working separately. This allowed us to send the PWM parameters and the range per the data acquired within colors. A 24 voltage DC with 30 amperes hour battery was chosen. To provide the proper current for each mode, we have an additional battery which allows us to charge a battery in the command station while the rover is being used in a test.
The antennas were taken to the anechoic chamber to be tested. This was done to measure the vibration pattern, assuring good communication between the control base and the rover. The antennas work at 2.45 GHz and 5 GHz. This gives us the possibility to change the frequency depending on the distance from the rover and the interference on those frequencies.
Hi, my name is Julian.
And my name is Daniela.
And we are part of the 5 members from the science team of Robocol. Our duty is to identify features from the rock samples collected by the rover.
First of all, we aim to determine the soil humidity, its subsurface temperature, and the conductivity of the sample, which are the minimal requirements of the University Rover Challenge.
Furthermore, we'll search for other attributes such as mineralogy or bioindicators, which will allow us to conclude whether there are suitable conditions for life to be supported or developed.